We have concluded the presentations for the EU policies, and before we pass to the EU technologies, I would ask if there is one question or one comment. We have time only for one short question or comment. No? So I have one. I have one question to Jack. What are, in your opinion, what we will achieve in Paris in COP21? Are you optimistic? What is your expectations? Could you share with us your opinions on what we are going to achieve? Thank you.
Thanks. Well, I think as any climate negotiator, we have to be professional optimists. So we have to keep coming back at this issue and trying again and trying with hope and optimism. But I think that there are some very good signs that we will do better this time than we've done in the past. And some of those have already been mentioned. The European Union's announcement of its 2030 climate and energy package. But then, of course, that was shortly followed by the announcements from the United States and China, which have never before participated in an international agreement with binding commitments before. And so the announcement of their intended targets at the end of last year was also very important in creating some momentum. We also have to create incentives for a broader set of countries to join, and that includes many developing countries that are struggling to find the resources in order to both make targets but also implement those targets. And a new fund has been set up, the Green Climate Fund, which has now received over $10 billion in commitments from developed countries and developing countries to help support that transformation. So we're optimistic. We think that there are reasons to be optimistic, and the way in which we're going about it this time, which is very much based on all parties identifying what they can do in an ambitious way, but that reflects their national circumstances, both within the EU, but also across the 195 parties. I think that approach, that sort of more bottom-up approach, also gives us hope that we'll be able to achieve targets that countries will both set but also implement once they join the agreement.
Thank you very much. And now we are going to start the debate on the EU technologies, best practice to be deployed worldwide. And the first presentation is going to be about wind power, a climate solution. And I will introduce Morten Dyrholm, is the Global Vice President of Public Affairs of Vestas. Thank you.
Thank you so much. That works. First of all, let me thank Claude for this fantastic presentation. I really enjoyed that enthusiasm. I'm not too sure, being from Copenhagen, that I like the phrase the Copenhagen syndrome. It signals something negative, but maybe the Copenhagen syndrome should signal something else, namely green growth and green business. Because what is really happening in Copenhagen and what is really happening in Europe, especially on the wind sector, is actually extremely positive. We are selling more wind turbines than we've ever done before. We're selling them to countries all across. It's quite a remarkable revolution we've seen. COP15, the result did not stop us selling turbines. On the contrary, we are now selling more than ever before. I want to give you some views from a wind turbine manufacturer here. Why is it that we are selling so many turbines? Why is it that the European wind turbine manufacturers are so successful? There are two main categories of reasons for that. One is on the climate side, of course. It's a clear climate solution. The other one is it's simply good business. So I will just start by talking a little bit about my company. For those of you who are not familiar with Vestas, then we are actually a European world leader within our segment. For more than 30 years, we have designed and manufactured and serviced wind turbines all across the globe. We are in 73 countries. We're 19,000 people. And we have 62% more installed capacity than our closest competitor, and 42 gigawatts of those are under current service contracts. Besides that, European manufacturers in wind in general are doing better and better. Solar PV might be another story in terms of where we are on a European competitiveness scale, but on the wind side, European companies are actually gaining ground this year. 6 out of 10 of the largest wind manufacturers are European, and they're gaining market share. So, in all fairness, we are a part of the success story of these foresighted European policies that Claude and the rest here have been talking about, and I think we should celebrate that. First, wind as a climate solution. Let me start with a practical example. We have installed 64 gigawatts of generating electricity, which equals the need of either Netherlands, Malaysia, Argentina, or the United Arab Emirates in terms of electricity need. And that's just the installed capacity of my company. These 64 gigawatts of wind, they offset CO2, equaling taking 33 million cars off the road. Wind power avoids emissions worth of hundreds of millions of tons of CO2 each year globally. And as the source of 2/3 of global CO2 emissions, changing the energy sector will be central in determining whether or not climate change goals are to be achieved. Over the past several decades, trends in emissions have followed those of the global economy closely, but they have shown increasing signs of divergence in more recent times. 1/4 less CO2 is emitted today per unit of economic output than in 1990. The IEA tracks this back to continued support for renewable energy and energy efficiency, an expansion of carbon pricing, and a partial removal of fossil fuel subsidies, of which there are around $600 billion a year globally. Regardless of CO2, conventional energy production also consumes water for energy production. And with drought following climate change, water shortages will have and are already having an impact on power generation in many parts of the world. So with wind, because wind turbines do not use water in production of energy, you get a climate-friendly, water-saving, ready available power solution. Now, my second point, why is wind energy a sound investment? If we accept that we need to act on climate change, which the scientific community and already impacted countries say we must, and if we accept that pricing carbon will be a future reality in some way or the other, then delaying action now will only make us pay more later. And the longer we wait to mitigate the detrimental levels of CO2 thrown into the atmosphere, the harder and more expensive it's going to be to work against the rising global warming. Following this logic, investing in renewable energy such as wind is an insurance for future cost increases. And it's not expensive to invest in wind or produce wind energy. Huge efforts have been done to reduce the levelized cost of energy by a combination of performance improvements, cost reductions, and maturing the supply chain. Wind energy is increasingly competitive, and according to Bloomberg New Energy Finance, the cost of energy for onshore wind has decreased by 12% in the last 5 years, whereas it increased 60% for coal and gas. The same Bloomberg has shown that the global average cost of energy for onshore wind has fallen an impressive 70% from 1984 to 2014, from $267 per megawatt hour to $82 today. Now, going forward, it is expected that wind's cost of energy will decrease by 10% towards 2020 and an additional 20% towards 2030. And these cost reductions are happening at the same time as we are increasing energy output from our technology. I just saw a figure yesterday, I think was also Bloomberg New Energy Finance. They said that in 2014, the renewable sector had attracted 270 billion euros in investment, which more or less corresponds to the previous peak year of 2011. But for that amount of money, we get the double of the capacity that we invested 4 years ago for the exact same amount of money. That says something about the development that this sector is going through. Let me give you another example. A 100 megawatt wind farm can be manufactured and built in a year and a half and bring power to 70,000 households. It's fast to ramp up, it's soon extremely competitive, and it uses endless amounts of clean fuel. But of course, there are also hurdles to deploy renewables. We've raised some of them today. Cost, subsidies, hotly debated topics, and there's no doubt about the increasing demands on our industry's ability to lower the cost of energy. While it might be true that renewables in the past have received too attractive support schemes, this is certainly not the case anymore. And we have to remember that the support that has historically been given has been extremely important. Exactly when we can develop subsidy-free wind energy for individual markets is not something we can put a specific date on. However, we can see more and more markets joining that club. And we have to remember that costs also depend on factors that are out of our control, such as future electricity prices, other electricity price drivers, market design, and political decisions about the economies of scale in the market. However, as I said, on select onshore locations with good wind, reaching grid parity is already happening, and some markets may reach grid parity sooner than others. We are getting there. And that leads me to my final point about which policies that can support this development. And again, allow me to use a practical example from the EU, because this is obviously the topic of today and has been mentioned, of course, already. But because of foresighted European policymakers that over the last many years have believed in the talent and the potential of the renewable sector, it has created a European renewable industry today which is a size comparable to the European steel industry. Today we are close to 300,000 people employed in the wind energy sector in Europe, and projections show that we will go to 500,000 in 2020. And 6 out of the global 10 wind turbine manufacturers are from the EU. 55% of all patents within the wind energy sector are from the EU. Through 2 renewable energy directives and a third one on the way for the period 2020 to 2030, the EU has supported and advanced the unique competitive advantage the EU now has in the renewable marketplace. It has set a target of 20% renewable sources in its final energy consumptions for 2020, and to achieve this, national action plans have been implemented. For the industry, this has provided us with a market to compete in. It has provided us with investor confidence and transparency in planning, which again has led to the technology development, the industrialization, and the cost reductions that we have seen. Others, of course, are catching up. I had the pleasure of working 4 years in China, and no doubt that the Chinese are betting heavily on the wind energy sector. Indicative figures show that in 2014, the Chinese will install some 20 gigawatts of wind energy, which is just mind-boggling, and I guess very close to half of the world market. Last week, I was in Gujarat to hear Mr. Modi, the Prime Minister, talk about 60 gigawatts of wind by 2022 and 100 gigawatts of solar by that same year. So they're trying to catch up, no doubt about that. But we have a head start. My point here is that the wind industry can deliver clean, competitive energy, but policymakers can secure the scale of a market to make cost reductions a reality. Finally, the recommendations for policies seen from my perspective. First of all, targets. Everyone understands how important that is. Firm targets that are ambitious create a line of sight and gives confidence to investors. Targets bring benefits such as innovation, industrial development, employment, and cost effectiveness. Secondly, certainty. Clear, unwavering, and incontestable policy roadmaps for the future inspire confidence. And changes to legislation should never be retroactive. We've seen that in Europe. It had a really damaging effect on the investor confidence. Incentives, we need to incentivize investments, but based on the principle of just enough to avoid overcompensation and stimulate further cost-reducing technological developments. We need to reduce red tape, Unbureaucratic administrative processes with short lead times encourage investments, and one-stop shops for permitting procedures. And last but not least, access to the grid and grid reinforcements are necessary in most cases of new power plants. All in all, the wind industry, as with any other industry, investors and lenders require stable and predictable investment conditions. Policy risks have a dominant influence on the investors' overall perceptions of risk, and therefore investments in renewables will happen if regulatory and political conditions promotes business case certainty. Thank you.
We'll turn now to solar photovoltaic, and we have a presentation by Mr. Christian Buchner from Schmidt. Schmidt is a machine manufacturer from Germany, and Mr. Christian Buchner is the Vice President of Business Union Photovoltaic. Thank you very much.
Maria, thank you very much for your kind introduction. Ladies and gentlemen, very happy to be invited here to present Schmidt today. And we are coming from the photovoltaic side. And first of all, Morten, thank you very much for your 5 recommendations. That's exactly what we also see for the PV. And of course, being in the renewable, I think we have to just take a look at both at wind and photovoltaics, which provides us with this future solution for renewable energy. And again, coming back to Claude's very passionate talk today, which I very much appreciate, also with the 1.5 billion people without power, I'm pretty sure they know already Coke Zero, but they don't know photovoltaic modules today, and that's what we have to really implement. So to start my presentation today, I want to give you a bit of information about Schmidt. Schmidt is a German company which is in the 5th generation family owned, and we have today 1,500 employees worldwide in 23 countries, 8 production manufacturing facilities, 5 technology centers in all key markets, and we of course certified and fully SAP integrated. So Schmidt today has altogether 5 business units. One of the biggest is the photovoltaic in this business unit. But we come from the PCB industry as a major supplier for manufacturing equipment for PCB industry, and diversified in the last years also towards optics and displays, industrial solutions, and very important also today for my speech into energy storage solutions. We do see energy storage solution as an important, crucial missing link to push the photovoltaic as well as the wind energy into the markets and ease the troubles net regulators have today to predict solar power or wind power, which is even more difficult to predict. So going back to the PV, we do take care today about the entire value chain. So Schmidt offers a full turnkey solution from silicon over wafer, cell, module manufacturing, and even to integration. So if you take a look at plants we typically design today, you see here a typical 1 gigawatt plant, 1.3 gigawatt, which could be in Saudi Arabia, for example, or even here. So that's what we provide today to our customers. And that's all supported by a strong investment into R&D. So we run huge capacity of researchers and centers to develop all the parts of the PV value chain into a very competitive area. So as Dominic Ristori said today, one of the very important things are innovation. And this is the dedication we have within Schmidt. We want to really drive photovoltaic innovation to provide the lowest levelized cost of energy solution for renewables. So you've seen all these pictures, I guess, in the past. I think globally we all believe that solar is giving a very good contribution to renewable energy supply. And what we always also have seen is, and it's very interesting, so we have been always ahead of the prediction people have done. And we do see this for the future too. And driving factors, of course, are, and that's important again, and coming back to Mr. Ristori's speech, we need political support, we need incentives, we need support from political arms in different countries to move ahead with being over the forecast in the future. And that, of course, is very important for equipment manufacturers like SHME too, so that also means that more equipment will be sold into the market and driving new technologies into manufacturing. Now coming back also to a similar slide we've seen from Germany to June 2014 that really very impressively demonstrates how much the contribution on energy can be. So we've seen a 26.7 gigawatt peak power that is distributed into the net. And here, exactly, you can see how important that is that you have also the right storage solution, because the next day it could be half, and it's very difficult to predict, and you have to regulate your network. The overview of levelized cost of energy, if you take a look in comparison to other nuclear, coal power stations, you already see in the MENA region where we are with photovoltaics. We are really at the lowest cost today possible. So how do we see the photovoltaics market? In brief, it has been a very fast developing market. So when in 1999 the German government imposed the renewable energy law, it just shoot it off. If you take a look at companies in Germany like Q-Cells, they started as a little backyard company, and suddenly they went off in sales and in manufacturing like crazy. So throughout the years, and at that time it of course has been a very new industry, the industry has matured to really a industry. So that's what we could see also in the last years, where typically like electronic industries, everything went into Asia. So China became the dominating manufacturing company along with Taiwan in the PV industry, and has really led and driven the PV cost down in the market, we have to say. But today we're again at a different point. Politics has changed the entire landscape again, with anti-dumping, with new incentives in new countries. And that's exactly what we do see. And this is very important now. This change goes from a pure part of the value manufacture, like solar cells or solar modules here, to people that regard solar as an energy provider. So it's not the business of selling any part of it in the value chain. Our customers today in new countries, they do look at the energy providing to decentralized grids. So today, the capacities in the established players are basically fully used, and minimal upgrades are visible today to minimize costs or increase efficiencies. China and Taiwan, as I said before, face serious impacts due to the anti-dumping, and the tier 1 players are trying to generate new technology USPs, but the primarily show project and marketing drivers dedicated market like Japan, new technologies like PERC, or we heard before heterojunctions. Uncertainty which technology to choose is throughout the industry very present today, and of course bankability here is a very important issue, because again you're talking now to energy providers who really understand to have sustainable source of energy for the next 30 years. So the PV fortunately has gained political attention in many new countries, and the desire to implement a full value chain, we can really see. And this is very important, including storage and being independent from China deliveries. With the new technologies, we do see very attractive cost of ownerships, and hence financing is also coming up again. And again, people are valuing quality as a key factor, especially if you talk to newcomers. So what are newcomers looking for? They look at fully integrated solutions, including the batteries, new technology to differentiate, customized solutions, well-defined and guaranteed quality, fast ramp-up, support for business cases, long-term partnerships. And here we stand for. Schmid has celebrated its 150 years anniversary last year. And of course, people are looking again to megawatt hour instead of megawatt peak. So if you take a look at the Schmid technologies, we started 3 years ago to research on battery solutions, and we decided for a vanadium redox flow battery technology. It's a battery technology that is very easy to implement in our projects today. It very well supports PV installations as well as wind installations and is based on a liquid vanadium pentoxide electrolyte that stores the energy, and it is, in comparison to a lithium-ion battery solution, a non-degrading solution that is infinite of life. If you take a look at the areas where we see the vanadium redox flow, we see it at the kilowatt local storage solutions, minute of power storage, we see it at the hours day storage, and of course also on the long storage between the kilowatt and to the two-digit megawatt regime. We have different solutions here for households as well as for big power station plants. The next technology we implemented into the photovoltaic industry is a multi-busbar solution on a new stringing technology in the modules that support the higher output of the modules and increase the efficiency of the modules and, of course, the optical appearance. A second very important new technology we have introduced last year is our Geminos line. That's a bifacial cell technology which enables, without adding any manufacturing cost, increase of efficiencies of 3% to a standard multicrystalline line. The interesting thing is here, the solar cell is slightly changed and does not only harvest the energy from the front side of the solar cell, but also with the reflected light from the rear side, and is a perfect solution for areas, of course, with sand, soil, as well as lots of sun irradiation. If you take a look, not only at, of course, on the efficiency gain, but on the cost gains you have, if you compare this technology, you increase only a 20% backlight irradiation, which is called albedo, of 9 US cents per watt peak at only 20% albedo. So now just a few examples of the Schmid's current projects coming out of basically the new technologies and the fact that our customers has changed. One example is Argentina, where we have a customer that comes from the power supply for mainly the mining areas. They were shipping gasoline every day up into the mountain areas on terrible roads, and with a lot of risks. So they decided to change that into photovoltaic power generation there. So this is a very good example of how new countries go into PV manufacturing locally, not on a huge scale, locally for the local demand. So here we provide wafer cell and modules at a 75 megawatt output annually for supporting local farms. Second is Russia. You've seen that Russia also has implemented incentives for Russian manufactured photovoltaic modules. So Schmid is starting in this year a project in Russia where we implement in 2 phases up to 200 megawatt peak cell and module manufacturing. And the third project is South America again, it's Mexico, same thing. And this is a light tower project for us because this really shows the usage of the battery not only in farms, but also in manufacturing. So this factory will be an entirely green manufacturing factory because it has not only the cell and module manufacturing, but also the local vanadium redox storage, so that the power they harvest from the modules that has been produced on the rooftop to manufacture again new modules. So that brings me to the end of my presentation. I thank you very much for your kind attention and open for questions. Thank you.
So before we break for the coffee break, is there any question for the last 2 speakers? If not, we will, please. We have a microphone, please.
My question is for the gentleman of the wind energy.
Martin.
Not a very good question, but it's necessary. Who is defending the birds? Because I think wind energy has always caused havoc to birds during migration. Is your company doing anything to further them somehow? Because no one is talking for them. Because we know that many places where they have the wind installation, that birds die on immigration. Thank you.
There was another question. Can we put them together?
Franklin, IA. First, I would like to congratulate you both presentations to see such a nice example of EU leading companies that can compete in the world. My question is, how much of your investments in the next 5 years are in Europe, and how much of your market share? And how this simple question, how many jobs you will create in Europe, or how you see European perspective is influencing your global view?
Can we have a short question, a short answer from each of the 2?
I think this works, yes. First on the birds and wildlife in general, then obviously this is something that the industry needs to take very serious. I will say though that, of course, I mean, you don't put wind turbines in the middle of migratory areas, etc., and there are sound, let's say, environmental assessments every time you put down a wind turbine anywhere in the world. Let's also try and put the problem a little bit in perspective here, because although we need to, of course, take care that any industrial building in the landscape minimizes the interference with nature as much as possible. If you compare the deaths of birds and wind turbines with electricity cords or just housing or whatever, then you'd see that wind turbines, the problem is extremely small compared to many other industrial buildings in nature. That is not the same as saying that the problem is not there. Let me underline that. I also want to stress that I see more and more wildlife associations who previously were skeptical towards wind power exactly for those reasons. That when you weigh that against the die-offs of birds due to climate change, then suddenly the equation changes a little bit. And we need to find that balance. And as far as I could understand, 25% of bird species in the US are in difficult, let's say, situations due to global warming. So what is the biggest problem in terms of bird deaths, etc.? I would say that climate change should be our focus. Again, fully underlining the responsibilities that we have as an industry also to protect the environment. On the European question, I cannot foresee the level of investments outside of Europe the next 5 years and how many jobs in Europe, etc. I can say that 2013 at least, we are tilting towards new and emerging markets. I mean, it is clear that larger and larger percentages of our sales are in South America, Southeast Asia, in Africa, and in other places, and where markets are booming. And Europe has been going through some challenges since the financial crisis hit us. But that's not the same as saying that Europe has disappeared as a market. It's still by far the most important region for a company like Vestas. So no doubts that the rest of the world will catch up, and we'll see more growth happening in new and emerging economies. But we still have a good shot at keeping the number 1 spot in Europe if we continue down the path that Claude and the others here have started.
Thank you very much, Mr. Buchner. Do you want to add something to the...
Yeah, real quick to the little German company. We are in the middle of the Black Forest. 150 years there. When I joined 10 years ago, we were like 150 employees, and we went into manufacturing in China. And of course, you can imagine in a city like 25,000 inhabitants, everybody was very angry about the fact that we moved into Asia, and we told them, no, that's necessary because that's our new market, but the driving motor still is in the Black Forest, and we are pretty proud about the machine manufacturing capabilities and the innovation that comes out of that little village there, and also, of course, of many other little companies, family-owned companies in Germany. And we've shown in the last 10 years, when we grew up to 1,500 employees, where more than half of it now is in Germany located. So we've grown really also the company in Germany, because innovation still comes out of Germany and new products come out of manufacturing in Germany. And of course, later will be transferred into manufacturing in China when you go into your price depreciation and fighting with competitors even out of China. But again, innovation is very important to us since 150 years and will stay, and we will create more jobs for sure.
Thank you very much. So we conclude the first part. We are going to have a coffee break of 15 minutes. So in my watch is 4:30 that we are back, or so just some minutes after 4:30. So please enjoy your coffee, and see you in 15 minutes. Thank you. Integrated solution to competitive PV power generation, please.
Yes, so good afternoon and welcome back after the coffee break. This is the wrong presentation. This is the next one. Already talk about the first slide and skip it later. I would like to take the time to introduce Manz AG as a company. So Manz AG is a company which provides high-tech manufacturing equipment to high-tech industries. So we provide manufacturing equipment to the PV industry, and this is the main reason what I want to focus here and talk about. But besides the PV industry, we provide as well manufacturing equipment to the lithium-ion battery business, to manufacturers of displays, liquid crystal displays, and also to some other industries as well. The company was founded in 1987. It's a family-owned company. It was founded by Dieter Mantz, and this is also the name of the company as of today. And Dieter Mantz is our CEO. Today we are around 2,000 employees. 500 of those are engineers. So this already imposes and stresses the meaning for the company of doing R&D, research and development. The turnover in 2014 is expected to be in the range of 300 million euros. And we are in the PV industry, providing manufacturing equipment for the PV industries since 1987. We provide as well turnkey equipment, manufacturing equipment and development in the CIGS area to provide solutions to manufacture CIGS thin film solar panels. So the next slide I also could talk about, but I would like to show you the graph because I love it very much. It's to show about the market and the market development. How much time do you need? Again, it talks about the potential of PV market. It shows a graph of the worldwide map. Okay, here we go. So again, it will show a map of a worldwide map with the installed PV power per inhabitant. So if you look on this map, you will see that there is 138 watt installed PV power in Europe per inhabitant, which means at the end, theoretically, everybody has 1 or 1.5 PV panels in his garden, and this provides enough power to probably switch on the TV set. If you look on other areas, here we go, thank you. So that's what I was talking about, the installed PV power per inhabitant in Europe of 138 watts. If you now have a look on the different regions like China, India, and the Sun Belt, you only see single-digit numbers. So in China, you have 6 watts. This means every inhabitant has enough power to enlight a LED, not more. India, even worse, Sun Belt region where we are today, nothing at all. So with this map, on the one hand, it's very promising because for me and for us as an equipment company, it shows the potential and the future growth of the PV sector. On the other hand, it also shows and proves with Europe and Australia that this shift in energy supply is really possible and that this shift can be done. So market intelligence talks about an installed capacity in 2017 of 420 gigawatt compared to about 100 gigawatt this year. So this means at the end, solar energy is a backbone of the future energy supply. Now we heard Mr. Buchner, my previous talker, about the crystalline silicon. I would like to show and discuss a different kind of technology. It was mentioned before as well. I want to talk about the CIGS technology, which is the leading thin film technology. With the CIGS technology, it's different to many solar energy technologies. In CIGS, we use no crystalline silicon to make the solar cell. We use vacuum processes. We use copper, indium, gallium, and selenide to create the absorber layer. In all thin film technologies, CIGS has the highest potential of all known materials in terms of efficiency, of conversion efficiency. A thin film panel is theoretically set up with a glass as a substrate. You cover and you coat this glass with an electrode, in this case a molybdenum electrode. This is the back electrode. In the next step, you do the coating of the absorber layer with only a thickness of 2 microns. On top of the absorber layer, you do the next coating, which is the front electrode, and this is the generic setup of a thin film module. At the end, you do an encapsulation and a cover glass on top. So with this setup of a thin film module, you have various advantages. On the one hand, we have the absorber layers, which is 90 times thinner than talking about crystalline silicon. So this means we need 90 times less of the expensive materials. In addition, you see in the module assembly is much easier, so this means you have less components involved in the bill of materials. And last but not least, if you compare the value-adding steps, the process steps to finish a crystalline silicon module with the one-step approach of a thin film module, it shows you have much less process steps involved, and this at the end results in a higher yield in the thin film production. So to make you, or to discuss the different processing steps, I would like to illustrate this with a video. So could you start this video, please? And turn down the volume, please. Okay. So this video is based and shows a concept study based on our CIGS cooperation technology. So this is the kind of material we use to make the absorber layer. We see again the generic setup, which is a glass, and then the various thin layers, lamination foil, and the cover glass. Here we see a concept study of a factory. This factory has an annual capacity of 150 megawatt. The entire factory building is in the range of 18,000 square meters. The production floor is in the range of 12,000 square meters. The entire land needed is in the range of 30,000 square meters. The production sequence starts with the loading of an architectural glass into the automated line. So it's a standard architectural glass having a thickness of 3 millimeters and a dimension of 1.2 meters by 600 millimeters. The glass gets cleaned by using DI water and some mechanical brushes. After cleaning, we check the glass for the effectiveness of the cleaning, but also whether there are any damages, marks, or skip outs on the edges. The next process step is to coat the back electrode, which is a moly layer. It's a PVD, a sputter process, and the moly layer applied here has a thickness of 400 nanometers. The moly layer is separated in different cells by means of laser scribing, and then the substrate is put into an automated corridor. This corridor serves at the one hand to connect the one process step with the next one, but it also serves as a buffer. The next step is the core of the entire factory, which is the process to apply the absorber layer. We use here a so-called co-evaporation process. The name says it already, so this means we evaporate all 4 elements at the same time and build instantaneously the absorber layer with a thickness of 2 microns. Afterwards, we have a wet chemistry process. So we form a reaction chamber. We apply the chemistry into the reaction chamber, and afterwards we place the entire reaction chamber into a water bath to get the chemical reaction agitated. After the wet chemistry process, we have additional laser scribing process, and then we do the coating of the front electrode, which is again a vacuum process, a sputter process. After this, we do a so-called laser edge ablation process. So this means remove all the layers on the outer edges. On the one hand, to achieve an electrical insulation to the outside and to get a good lamination process. We do a contacting at the outer cells, and after module assembly, so putting the cover glass on top, we do the assembly of the junction box, and finally a testing of the module of the finished product with a Sun simulator. And so you have a finished product out of the line. You can stop the video now, please. So far, the manufacturing processes, we are in the Mid-East region, and I want to present here a case study which we calculated for Saudi Arabia. So based on such a manufacturing line with an annual capacity of 150 megawatt, you will achieve a OPEX, this means a manufacturing cost of 35 euro cents per watt peak. This is the one number, but important here to note as well is that if you see the chart here, about 70% of the OPEX relates to variable costs. Out of these 70%, almost 90% is based on the material cost. So on the one hand, this shows and allows the potential to really go for local sourcing and establish a local industry around such a manufacturing line. On the other hand, it also emphasizes the importance of R&D work, because the only key to drive down manufacturing cost here is to increase the efficiency. An increase of efficiency you only can do with R&D work, with development in Germany. So we have an exclusive cooperation ongoing here with research organizations in Germany, close to our headquarters. This institute is called CSW, and CSW owns the world record in this material with 21.7%. The task now is to really transfer the know-how and IP of this research institute into application, and to make it applicable for industrial use. So the one task is, of course, to provide a PV panel with high efficiency or highest efficiency at lowest cost. On the other hand, we talked about and heard about this before, it is important about the energy harvest, because at the end this panel is installed in the field and we want to get electricity out of it. Therefore, even we are a machine supplier, we run various test sites. We run ground-mounted systems, rooftop systems, and building integrated systems. We also run test sites here in the Mid-East region. We have a test site in Qatar. We have 2 test sites in Saudi Arabia, one in Dammam, one in Riyadh, and we are just setting up a 3rd one in Jeddah at the Coast Campus. For us as a machine supplier, it's important to know how the product will perform in the field, and to support our potential customers with this know-how and IP. All of those test sites, you see a graph here, show more or less the same results. The CIGS panels perform superior compared to crystalline silicon panels based on the better temperature coefficient. So the better energy harvest at the end results in very attractive levelized cost of energy. Again, a calculation here for the Mid-East region based on the lowest manufacturing cost. We end up here with levelized cost of energy in the range of 3 euro cents per kilowatt hour. So we did here a comparison with a power generating company, so PGC, power generating company, which has in addition a CIGS fab to manufacture these panels. And we did as well a comparison here with competitive technologies, so power generating companies with crystalline silicon modules. At the end, the highest performance in the levelized cost of energy result as well in very attractive IRRs for the investment. But again, if we talk about Mid-East region, if we talk about Saudi Arabia, as long as their oil is burned and the barrel of oil they burn to generate electricity power, they calculate with $10, you won't even be competitive with 3 euro cents per kilowatt hours, levelized cost of energy. At that stage, there is another dimension coming into the game, which is the political dimension. We heard about Saudi Arabia, who wants to install 41 gigawatt of renewable energy. With this, Saudi Arabia wants to establish a local industry. They want to build a local industry around this renewable energy process. So this means, of course, we want to provide the equipment. But in addition to the equipment, we provide access to IP and technology, we provide the access to education and training, and we provide the access to services, after-sale services. So through our partners like CSW and KIT, we also can provide access to bachelor programs, master programs, and at the end also to PhD programs. And this is, again, which is very important to make those models work in these regions. So last but not least, please allow me some conclusion remarks. So based on the highest efficiencies, and there, as a result thereof, with the lowest OPEX, based on the very good performance in the excellent hot climate coefficients, we have a result of lowest levelized cost of energy. And in addition, with the solution, we provide a solution to really develop a local industry, and therefore we are looking forward to make this work in this region and to get a higher percentage of PV installed in the Mid-East region. Thank you very much.